Hello everyone, more U-Sub here. We have a rational function 9 over 4x squared plus 9, right? So um, before we actually see how we can do this integration, let's just review one fact here because this function, as you can see, it looks like there is something that will involve the arctangent. And then you may say, what about the arctangent? It's this. Let's just review that the antiderivative of a simple rational function, and that function is 1 over x squared. And you can also write it as x squared plus 1. And if you integrate this function, you are going to get arctangent of x and then plus the constant. Okay, so as you can see here, this function that we are trying to integrate right now looks really like the 1 over 1 plus x squared. The difference is that instead of adding the 1 here, we have 9, and then also the number at the top is it's not a 1 either. And then another difference is that the coefficient for this x squared right here, it's 1, but for our problem, the x squared, it has a coefficient of 4. And so there are a lot of different things that they're different, but then we can actually try to manipulate so that we can turn our function in this form, then we can use this fact. Okay, so let's get started for the problem. First thing, we are going to just pull the 9 outside the integral, then we are going to get 9 times, let me just write it here, 9 times the integral, which is 1 over, now it's 1, right? So we have 4x squared plus 9, and then times the dx. Okay, so that's first step. And then the next step is that we actually want to turn this 9 into a 1. And if you want to do that, then what do? We really just want to just factor the 9 from both terms in the denominator. Then we can turn this into a 1, right? We cannot subtract by 8 because if we subtract the 8, then we also need to add the 8 back. Okay, so we need to factor. The 9 stays outside the integral. And then there is we factor the 9 so that now we have a 9 in the front. And then you are going to get what? Let me just rewrite this. Then longer fraction line for that. Okay. If we factor the 9 from the 4, then we are going to get 4 over 9. And then times x squared. And as you can see here, if you multiply this 9 back to the 4 over 9, the 9s will get cancelled, those two 9s. And then you are still going to get just the 4x squared, which is our original problem. Okay. And for the other 9, then you are going to get a 1 here, right? Plus 1, because we factor the 9. And then there was still a dx in there. Okay, next step. This 9 right here, we can pull it outside the integral, which will cancel with this 9 in the numerator. That 9 is in the denominator, so they get canceled. So we can actually just cross them out right now. So we can cancel them. Actually, let me use a different color for this. So we cancel them, then we are going to get the integral of 1 over 4 over 9 x squared, and then plus 1, and then times dx. Then you may say, right now, it looks more like this form. We have a 1 at the top. We have a 1 that's by itself, right? You're adding the 1. The difference is that for the x squared, we do have a coefficient of 4 over 9, right? And there is one way that we can turn it into a form with just some quantity square. And that quantity, instead of having just the x, we can have a number multiplied to the x. And then the whole thing square. And what we can do is that we can just write that 4 over 9 x squared as this. So we have the 1 here, and then let me just put down all the other stuff first. Yeah, so we can write it as some quantity square and then plus 1. Okay, so that actually has the same form as this one because we shouldn't have a number other than 1 in front of the whole square, as you can see here. So what we want to do is that we actually want to turn this 4 over 9 x squared into some stuff. and then you square that. And what is that? We got to fill in this blank in here. The blank is actually not too hard to fill in. You just need to think about what square will give you the 4 over 9. And that number would be 2 over 3. Yeah, so you square the 2, then you're going to get the 4. You square the 3, you're going to get the 9. So you get 2 over 3. And then there was something that you also need to put here, that when you square it, it will give you x squared. And so that's something, it will be easy, right? It's just x. Okay, so now we have 1 over something squared plus 1, and that's actually the same form as this one. So now we can perform a U-sub on this thing, then we can have our answer. So what we are going to do is that we are going to just do it on the side right here. This is not part of the big picture of the problem, so we can just do the U-sub on the side. So we are going to let U be this stuff, right? 2 over 3 and then times x. And so the du will just be 2 over 3 and then dx. And now if you just look at this problem here, we have just the dx. We do not really have a 2 over 3, so you can actually isolate the dx and then multiply by the reciprocal of this 2 over 3, and then you can get the that number on this side, right? So if you multiply by the reciprocal, then it's going to look like what? You're going to get 3 over 2. So that's our reciprocal, and then you do the same thing here. And so those things, they get canceled. And then you are just going to get the dx isolated on one side. So we have the dx on the right side, and then you have 3 over 2 du on the left side. Okay, so now we can make that substitution in here. So going back to our original integral, we are going to get the integral, and then there was the 1 at the top. Okay. And then what do we have in the denominator? We are going to replace this 2 over 3 by the u. So we are going to get u squared plus 1. And then what about the dx? The dx is replaced by this 3 over 2 du. So let's do that. So we go to our integral and then just put this right here. So we are going to get 3 over 2 and then times the du. So now because this 3 over 2 is a constant, we can put outside the integral. Then it becomes 3 over 2. And then we have the integral of 1 over just the u squared plus 1 and then du. And then now, as you can see here, this integral is the exact same thing, except that the variable is u. So we can just integrate by using this fact, right? So that's equal to tangent inverse of whatever variable that you have here. In that case, that's x, but for our problem, it's u. So we are going to get 3 over 2. Okay, and then the integral becomes tangent inverse of u. And then, of course, we just need to do one more step. We just need to just replace the u with our original expression for the u involving x. So we are going to get, what is that? That's 2 over 3. Our u-sub was make here, right? So we put it back in here. So we get 2 over 3x. And then plus the constant. So we put plus a c. And so that's our final answer. And if you differentiate this, you can verify that the answer will be the same thing here, but then you may need to do some algebra manipulation to get it into this form. Okay, so that's a simple U-sub problem, but sometimes we just need to recognize that, okay, so this function, we cannot just let u be 4x squared plus 9 because there is no x at the top for us to cancel out that the ax, right? So if you see a function in this kind of form, you may start to just think about whether we should be using this fact right here. This is the when you integrate this 1 over 1 plus x squared will give you the arctangent function. And yeah, so just make sure that you relate this into this form. And then of course we got to do some algebra manipulation to turn our function into that form. Okay, so that's it for this problem. And if you like my video, please subscribe to my channel and give me some support. Thank you, and I will see you next time.